Okay, so we finally get to the predictive technologies. These are the big 6 predictive maintenance technologies, and I'll start with an overview to give you an idea of what each one of them does. So my personal favorite, because this was my first job when I graduated from school, is vibration. Vibration, if you can imagine, most of the faults that we encounter in machinery, whether they be bearing faults or misalignment or degradation of the base plate, for example, all of those tend to cause the machine to vibrate in a way that we don't want. And simply stated, the art of vibration analysis is measuring that vibration in a very precise way that we'll get into later when we do data analysis, but measuring that vibration and then trying to infer from the vibration signature what might be wrong with the machine. The amazing thing is this is actually a 50-year-old technology that has a really well-established body of knowledge. What's new is the ability to suddenly do wireless IoT systems with vibration sensors in them. So it's the best of all worlds. You have a new wave of vibration sensors being installed. However, the underlying fundamental engineering analysis has been laid out over the course of 50 years. So a great technology to adopt. Next up, thermography. Thermography resembles night vision goggles, and so it's using the same principles. It turns out that different bodies, bodies being a machine or objects, different bodies radiate temperature depending upon the temperature that they are at. It's most commonly used for electrical switchgear and fuses and other types of connectors, but can also be used for mechanical faults. If you think about it, whenever a bearing is undergoing significant amount of wear, that will cause the bearing housing to heat up. Whenever actually the coupling itself, if you have a misaligned machine, the coupling itself experiences internal friction, and that'll tend to make that get hotter as well. So thermography is, what I love about it is it's dead easy to understand the basics. You're simply holding a camera that shows you a visible image colored in red to yellow to blue to give you an understanding of what's hot and what's not. Very versatile technology. Goes very deep in the fundamentals. However, just about anybody can be up and running very quickly with thermography. Oil analysis. This one is actually not one technology, but it's more like a cluster of a dozen different lab-based technologies. What they all have in common is you draw an oil sample from the sump, most commonly of your bearing housings, but also from sumps for hydraulic systems, for example. And then you take that sample and you send it to a lab. If you're lucky, you might have a lab right directly on your site. In the vast majority of cases, that's outsourced. The lab then looks at that oil sample and they identify, do I see contaminants? That means that dirt is getting in and we need to find a way to stop that. Do I see water? Water is the enemy of all types of lubricants and hydraulics. We don't want water inside of our oils. Or number 3, really important for predictive maintenance, do I see wear particles that match the materials of the bearing or of the machinery? That is a really big red flag that lets you know that you've probably got a rub if it's a sleeve bearing or degradation if it's a roller bearing, and you want to make sure to get that addressed right away. So think of oil analysis not as one technology, but really 12 different technologies, all of which tend to get tested in a third-party lab. Next up, ultrasonics. Ultrasonics is fabulous for 3 really niche use cases. Number 1 is bearings. So when you take an ultrasonic probe and you push it directly against a bearing housing, you can hear a really notable gravelly sound if the bearing has a fault, and a much smoother sound if the bearing does not. Super visceral, really easy to understand, so that's the first great application of ultrasonics. A second one is for leaks. If you're looking for leaks in a compressed air system, it turns out that you can put on headphones and then use a nozzle on the ultrasound gun to point it directly at where you might be experiencing a leak, and then it's really impressive when you do these walk-arounds. It's like night and day. You will hear the leak loud and clear when you're pointed directly at whatever seam happens to be leaking. So great when you have a compressed air system that you know is leaking and you just can't figure out where that's coming from. Ultrasonics are really good. And I would call the third area specialty. You can sometimes use them for identifying corona discharges or arcing inside of a panel, or corona discharges even far away for like electrical T&D equipment. And also things like steam traps. So steam traps, turns out that about a 25 kilohertz band, plus or minus 1 kilohertz, if you put a probe against a steam trap, you can tell a lot of the failure modes of a steam trap using an ultrasonic probe. So that's a fun technology as well. All right, next up is MCSA, motor current signature analysis. I like to think of this as a sister technology to vibration. The type of data that you're collecting in MCSA, from a technical standpoint, is nearly identical to vibration, except in MCSA, what you're taking is really rapid time series samples of the motor current for each of the leads, as contrasted with the actual mechanical vibration of the machine. But really, both of them are looking at a lot of the same failure modes. And what I love is that when you use MCSA, if you see the signature of a particular mechanical fault, both in vibration and in MCSA, you're approaching 100% assurance that that fault is really happening, because these are completely unrelated technologies that just so happen to have very similar analysis methods that point to the same failure modes. And then finally, motion amplification. Number 6, motion amplification is the newest of these 6 technologies. This is really cool. I like to say that if I were to name this, I would call it motion amplification and time dilation. That's a mouthful, and that's why I'm not a marketer, but what it does is, if I were standing looking at a machine that was experiencing excessive vibration because of resonance, say, I wouldn't be able to see with my naked eye that actual resonance structure. And the reason is, number 1, the motion is too small, like our eyes simply can't resolve these milli-inches of movement. And number 2, it's too fast. So these vibrations are happening really fast, and the eye also can't resolve that type of a time domain. However, if you take an algorithm and both a camera and a really cleverly developed algorithm, you can both expand the motion that you're seeing, amplify the motion that you're seeing, and slow down or dilate time so that you can see it actually in a very visual way moving back and forth. This was a really cool breakthrough. Roughly a decade or so, this was innovated by a company called RDI Technologies. So this is a lot of fun to play with. It's the newest of the big 6 and should definitely be in your consideration set for your overall predictive maintenance program.
If we're not doing any of this, where's the easiest place for us to start?
Great question. I would probably start with vibration and thermography. Now, vibration is very difficult if you're doing it yourself, but there are a lot of offerings on the market now where you can install IoT-based vibration sensors, so air-gapped wireless sensors, and the vendor can do the hardcore analysis and then partner with you to let you know they're seeing the signature for a particular type of failure mode, and then your technicians on the ground floor can be the eyes and ears on the street and send pictures and lay hands on the machine. So I would consider, as a first step, outsourcing the vibration program and partnering with a company that gives you the IoT-based system. And thermography is easier to insource. It is typically done in a walk-around route-based fashion, but you can buy a relatively inexpensive camera, a thermal imaging camera, and as long as you obey a couple of rules that involve emissivity, that we'll get into later, you can get a lot of great information right out of the bat, because it's so intuitive. You're looking at what looks to you like a visual image. What it actually is a radiometric image, but it looks like the actual picture of the pump. And you can see very clearly, here's a red spot, that's a hot spot. Here's a blue spot, that's a cool spot. It lets you see a lot of the low-hanging fruit really easily. So these are my 2 favorite to start with. But I am a fan of all 6. The best programs utilize all 6, but if I had to pick 2, that's where I would start. And then importantly, if you're just starting your journey and want to adopt these technologies, you want to make sure that you understand the ROI. And we've got a separate video that goes into the big 6 benefits of predictive maintenance. And that really articulates clearly the ROI that you want to use to get the funding approved.